And good morning everyone. Okay, so for this video I will explain on the topic for integration. Okay, so what you will learn on this is list the standard of integration of x to the power of n and e to the power of x, and you will differentiate the indefinite integral and definite integral, and then you will learn how to evaluate their antiderivative of simple algebraic function and also simple exponential function, and also you will go through the another subtopic, which is area under the curve and area between two curves. Okay, so before this we learn differentiation, right? So what is actually integration? Integration is actually a reverse process of differentiation. Okay, so when we differentiate, we're going to get a function. So let's say if we integrate this function after we differentiate just now, when we do integration, you're going to get the original function before you differentiate. So usually when the form of differentiation is integrate, you see the curly symbol like this. So if you integrate it, you're gonna get the original function. So I'll show you how. So let's say if we have fx is equal to 5x to the power of 3, and then I differentiate this. Okay, differentiate, I will get fx. Remember, when we differentiate, if differentiate x to the power of n, you're gonna get x to the power of, if you differentiate, so you bring the power in front, and x to the power of n minus 1. So this is how you differentiate. So you copy 5x to the power of 3, you bring in front. Okay, so by right, 3 you multiply with 5 here, x to the power of 3 you maintain minus with 1, so the answer is 15x to the power of 2. Okay, now let's say if I have a function which is from 15x squared just now, and then I want to integrate. Okay, if I want to integrate, by right, what I will have to do is, I have a function, right, 15x squared, I have to put this curly symbol and dx at the back to inform the one, to show that we are actually integrating this with respect to the variable x. So when you integrate, by right, f prime x is 15x squared, right? So dx, so we will integrate x symbol here. The first step is, when you integrate, you should do like this. If you have x to the power of n, first step is we plus the power, and then you divide with n plus 1. So right now we have 15x squared, the power with plus 1, you're gonna get equal to 3, right? Then you divide with 3. So here you put plus c, this one you must put, and then you're gonna get here, if you cross, you'll get 3x, sorry, it's not 3, 5x to the power of 3 plus with c, which is, if you see here, it is actually the same as our original function. Okay, so that is why we say that integration is actually the reverse process of differentiation. Okay, now we proceed to basic rules of integration. Just like same as when we do differentiation, we have rules. So for integration, we also have rules. Okay, the first one is when you have to integrate 1. Okay, when you have to integrate 1, okay, when you integrate 1, you're going to get x plus c. Okay, or if you have to integrate dx, still you're going to get xy, because dx is actually 1 multiplied with dx bar, 1 multiplied with dx. So when we integrate this guy, we're still going to get x plus c lah. Okay, and then if you integrate 0, you're going to get c. Okay, just put c. And then if you have a variable, you're going to get variable k, I put here, so any number lah. Let's say it could be 6 dx. So when you integrate, don't forget to put x at the back, copy 6, put x at the back plus with c. Okay, C here is actually arbitrary constant or a constant of the integration. So when we differentiate any constant, right, the derivative is 0. So that's why when we go backward, integrate, we actually don't know what constant was actually at the original function. So that's why we just put C. Okay. So now the most important rule here, okay, which is for integration function, when you have x to the power of n, and then this is only work for when n is not equal to, this one, sorry, I think I make a mistake, it's supposed to be when n is not equal to -1. Okay, when you have xn, when you want to integrate it, the first step is you copy x to the power of n, okay, and then the power you plus 1, remember power plus 1 divide with total power here, n plus 1, then you plus c long. Okay, so we go through example. Here we integrate x to the power of 7 x to the power of 7 dx. So the first step is you copy x to the power of 7, then you plus 1 divide with 7 plus 1, which is you're going to get equal to 8. Here you put plus c, so you're going to get x to the power of 8 divided with 8 plus with c. This is how you do it lah. Okay, now we go through the next example where we have 2x to the power of 4. Remember the first step, we copy the whole thing first, 2x to the power of 4. And for this one, plus 1. The power you plus 1, so 4 plus 1 become 5. So plus with c. Here you will get 2x to the power of 5 divide with 5 plus with c, which I think you're going to see this question in a tutorial, I believe. Remember to put c, because c here, it actually has mark. If in exam you forgot to put, then we will deduct the marks, even though once you integrate, your function is correct. Okay, so we proceed to the next question. We proceed to the next one, okay, where we have here when your n is equal to -1. Okay, when n is equal to -1. Okay, by right, before this, okay, when we learn differentiation, right, when you differentiate ln x, okay, you differentiate ln x, if follow the rule, you will get x, 1 over x. Okay, so remember when we actually remember when the definition of integration is a reverse process of differentiation, right? Integration. So what happened is, so when you differentiate ln x, you're going to get 1 over x. When you integrate 1 over x, you're going to go back to ln x. So here, if you see 1 over x is actually 1 over x here, it is actually x to the power of -1, right? Okay, so when you have to integrate when x to the power of n, okay, and then your n here is equal to -1, okay, by right, once you integrate 1 over x, you will go back to the ln x plus with c. So anything that is 1 over x, you're going to get ln x. Remember, only for 1 over x or x to the power of -1. Other than that, you have to use the previous one lah. This one. Okay. Now we proceed to the next question where we have I think we should go through example this one first, where we can see here, right, 3x to the power of 5. When we integrate, if you check here the power, it is actually x to the power is actually n is equal to 5, right? So we can use the basic rule, which is when you have x to the power of n, you plus 1 divide with n plus 1. So we will apply here also. So you copy lah. The first step, copy the whole function here, 3x to the power of 5 plus with 1 divide with 5 plus 1 is 6. So 3 and 6 here, what you actually can do, you can cross them lah. Okay, and then 3 divided by 6, you're going to get 1 and then 2 here, At the back you plus with c. So final answer is x to the power of 6 divided with 2 plus with c. Or you want to put 1 over 2 x to the power of 6 plus c also can. Okay. Now, the next one we have integrate 1 over x to the power of 4. Okay. This is a very common issue that you're going to see when you solve integration. So when your denominator, you have fraction, right? When your denominator, you have x to the power of 4. Okay. So denominator, you have x, variable x with power something. What you have to do is you have to change this into index, which is your 1 over x to the power of 4, you change to x to the power of negative 4. Okay, you change to the power of negative 4, then you can start to integrate like this. So this is x to the power of negative 4, right? Then we integrate them. You copy first x to the power of negative 4, power plus 1, divide with negative 4 plus 1, you're going to get negative 3. And don't forget to put plus c at the back. So here you will get x to the power of negative 3 minus, divide with negative 3 plus with c, or you want to make it prettier, 1 over negative 1 over 3 x to the power of negative 3 plus c. Or if you don't like this one, you can change to, from here you can change to negative 1 over 3x to the power of 3 plus c. But then if you write up until here, we still allow up until this one. Okay. Now we proceed to the next question. Okay, the next question. Okay, here we have x to the power of 3 plus 1 divided with x. And if you see here, at the denominator, we got x, right? So the first step, when you have x here, okay, you have to know that we have to change this to index. Okay, change this to index, and then we have plus in the middle, right? You separate them. So from here, so x to the power of 3 plus 1 divided with x dx, you separate them. X to the power of 3 divided with x plus with 1 divided with x dx. Okay, the next step, if you see x to the power of 3 divided with x, you're going to get equal to x to the power of 2 plus with 1 over x. When you have more than one term like this, okay, you have to integrate one by one, because before the previous question is only one term. Now we have two terms, which is x squared and 1 over x. And then we proceed, yeah? So we can integrate as usual. It's just that you have to do one by one. So you copy first x squared. You integrate x squared. Remember, power plus 1 divide with total power, which is 2 plus 1 equal to 3. Now plus with 1 over x. When we integrate, become what? We cannot do the normal one. We have to change this to ln x, because it is actually 1 over x is actually x to the power of negative 1, right? Which is when n is equal to negative 1, you have to use ln. Okay? So, here don't forget to put plus c. Then you will get x to the power of 3 divided with 3 plus with ln x plus with c. So that's it for this question. Okay, we proceed to the next one, where we have integration of function e to the power of x, which is exponential. Okay, now we know that when we differentiate, we have function e to the power of x. When we differentiate this guy, okay, you're gonna get e to the power of x, and then you have to differentiate the power, which is the power here is x. So you're gonna get equal to e to the power of x. Differentiate, x become 1. So you multiply with 1, the answer is e to the power of x, right? So also similar, let's say if you have e to the power of 2x, when you want to differentiate this guy, so you copy the whole thing, e to the power of 2x, multiply with the power here, we have 2x. So differentiate 2x, you're going to get equal to 2. So the final answer for this one is 2e to the power of 2x. So this is how you do the differentiation. You multiply with the differentiation of the power. Also similar with integration, So the first step is you copy e to the power of x. Okay, and then here, when you want to integrate them, copy e to the power of x, divide with differentiation of the power, which is the power is x, and then plus with c. So e to the power of x, differentiate x, you're going to get 1. Then the answer is ex plus c. So that's why we can do this rule lah. Okay, so let's say if I have integrate e to the power of 5x dx. When I want to integrate this, you copy first e to the power of 5x, multiply with differentiation of 5x, which when you differentiate 5x, you're going to get equal to 5. So the answer is when e to the power of 5x multiply with 5 is 5e to the power of 5x plus with c. Don't forget to put on. Sorry, I made a mistake here. This is differentiation. Sorry, So from here you divide, e to the power of 5x, you divide with differentiation of the power. Okay, here you will get e to the power of 5x divide with 5 plus with c. So the answer is 1 over 5 e to the power of 5x plus with c. Also can to do like this, or this one also can. Both are acceptable. Sorry for the confusion. Okay, now we'll proceed to the indefinite integral. Okay, so the one definite integral, the one that we do previously is actually indefinite integral, where we don't have interval or upper limit. So by right, when we do indefinite integral, we just want to know the general. And then here, for definite integral, you actually have upper limit and lower limit. By right, what you want to know is, you want to know the value of integration when it start at x equal to, let's say I give you example, equal to a until b. So when I integrate, I want to know the integral of this function starting from x is equal to 0 until x is equal to 2. So what I have to do is I have to substitute the upper limit and lower limit. So where is upper limit and lower limit? This is lower limit. This is upper limit. So when you integrate, you're going to get a function, right? But then, since you have lower and upper limit, you have to substitute them one by one. So by right, the first step is substitute b inside the upper limit, and then you minus with minus with the function that you substitute lower limit. Okay, so by right here, you have to substitute upper limit, and minus with substitute the lower limit. Okay, so easy for you to see. We just straight away do example. So this is actually 3x to the power of 5, which is coming from the previous. Okay, so when the first step is here, if you see, we have 1 and 2. Okay, so when we do here integration, the same method, which is we have to integrate. So integrate what? 3x to the power of 5. So you copy 3x to the power of 5, and then the next step is the power, we plus 1, divide with 5 plus 1 becomes 6. So you cross this one. This one become 2, this one become 1. It is coming from the previous question, and then once you do this one, right, do we have to put c? No need. Why? Because this is definite integral, so you have to put square bracket. And then you see upper and lower limit, this is your a, this is your b, so you put 1 and 2 like this. And then you're gonna get x to the power of 6 divided with 2, 1 to 2, right? What you have to do is, this is your upper limit, you substitute 2 inside x that you have, which is 2 to the power of 6 divided with 2. And then you minus with the lower limit, which is 1 to the power of 6 divided with 2. The final answer you're going to get is 31, 1 over 2 unit square. Okay, so this is how you do for this question. Now the next one, let's say if we have 1 over x to the power of 4, and then the upper limit it is integrate starting from 1 until 2. So here 1 over 4, when you integrate, you actually got, check from the previous question, we got negative 1 over 3x to the power of 3. So here we can do again. I just show it to you again. So you integrate 1 over x to the power of 4. You're gonna change it to x to the power of negative 4. Okay, and then you will start integrate 1 until 2. Then copy first x to the power of negative 4. Power plus 1, divide with negative 4 plus 1 become negative 3. Put bracket, put the upper and lower limit. So here you're going to get x to the power of negative 3 divide with negative 3. Okay, the next step is you substitute the upper limit into x. So you substitute 2 to the power of negative 3. Okay, divide with negative 3 minus with, you substitute 1 into x, so 1 to the power of negative 3 divide with negative 3. Okay, or you want to do fraction also can, it's up to you lah. Okay, this one you substitute inside calculator, you gonna get equal to negative 1 over 24 minus with negative 1 over 3. So you will get negative, the final answer, because negative and negative become positive, right? So negative 1 over 24 plus with 1 over 3, final answer is 7 over 24 unit square. Okay, so if you see the differentiation between the integral and definite integral and indefinite integral is that for indefinite integral we have to put plus c. For definite integral, we have at our final answer we have to give the number value instead of variable. Okay, we'll go through another example so you can see inside your exercise. Okay, so we have x to the power of 3 integrate starting from 0 to 1. So the first step, you copy the function x to the power of 3. The power, what we're going to do? Plus 1, divide with 3 plus 1 become 4. So here, you put square bracket 0 to 1. Then inside become x to the power of 4 divided with 4, 0 to 1. Now the first step, you take the upper limit, substitute into x. You're going to get 1 to the power of 4 divided with 4. Minus with, you substitute the lower limit, 0 to the power of 4 divided with 4. So 1 over 4 minus with 0. Then the final answer is 1 over 4 unit square. Okay, now we will go through the properties of definite integral. Okay, so when you integrate any function, then if you see here the integral, the upper and lower limit is the same, then you're going to get 0. So let's say if you have x square dx, they ask you integrate x square starting from 1 to 1. The answer is 0. Okay, and then here got typo. If they ask you to integrate a to b, actually you can change this, okay, to a to b. So what happen if, let's say if I have if I have integration of 5x dx, integrate from 1 to 2, I got 2, let's say. When I have integration of 5x, but then I swap the upper and lower limit 2 to 1. Okay, if you see here different, this one different, right? So what I have to do is here, this position is changed, right? Then you just put negative 2. No need to calculate, straight away put negative 2 when the position of the upper and lower limit they swap. Okay, let's say you got negative 2, by right here you will get positive 2. Okay, and then here you have integration of k fx dx. You can bring k outside. Let's say if you have 5x square dx 0 to 1, you can actually bring 5 outside, integrate x square dx 0 to 1. Then you can, once you integrate x square from 0 to 1, you just multiply with 5, then you get the answer. Okay, and then here if you have two terms, we separate lah, just like how we do for the previous question just now for that one, x to the power of 3 plus 1 over x. We have to do one by one, right? So also the same lah for this one, we just do one by one. Okay, now we use the properties of definite integral to express the definite integral of fx negative 3x square and negative 3x to the power of 3 plus 2x plus 2 over the interval negative 2, 1 as the sum of the three definite integral. They said to use the sum of three definite integral. So here, right, they ask us to use the definite integral that we learned just now. So by right, you have negative 3x cubed plus 2x plus 2 dx. You have to integrate starting from negative 2 to 1. And then you separate them. Negative 3x cubed dx. Follow the number 4 rule. Okay, so do one by one. So you copy negative 2, 1, and then you separate them again. Take the second term, which is 2x dx, starting from negative 2, 1. Separate them. 2 also integrate 2 dx starting from negative 2 to 1. And from here, you also can bring negative 3 outside because negative 3 is a constant. So negative 2, 1, and then you bring 2 outside. Then you bring this one. If you want to bring outside also can. No, don't want to bring outside also can. It's up to you. 2 dx negative 2, 1. And then you can solve this. As usual. Do one by one lah. Okay. Now we proceed to another properties of definite integral. This one is okay, no need for you to know. This one is also important, which is if fx is integrable on interval joining a, b and c, where a is less than b, less than c. So what you have to do is, let's say if you have a function here and then it is a to c, you actually can separate them, but then you can separate from a to b, b to c. So what is the value of p here? It should be between the range that you have. Okay, let's say I give you an example. If I have a function x to the power of 3 dx starting from 1 to 5, I can actually separate them. Okay, x to the power of 3 dx. Okay, integrate starting from 1 to 3 plus with I integrate x to the power of 3 dx again starting from 3 to 5. The most important thing here is that you have to know that you have 1 and 5, right? So you have 1 and 5. So you must start with 1 and finish with 5, but then the value that is in the middle, it should be the same as b, which is if you have a to b, a to c, in the middle you have b. So that's why if you have x is equal to 1, c is equal to 5, b, it can be any value that is between this range according. So this one also have to follow the type of question lah. Okay, now we proceed to example. Okay, you have if it is known as fx integrate from 0 to 8 is equal to 10 and fx integrate 0 to 5 equal to 5, find the value of fx integrate 5 to 8. Okay, so here they provide to us information already, which is this guy. Okay, 0 to 8 is 10, 0 to 5 is 5. Now they want us to find 5 to 8. Okay, the first step is you copy first. Fx dx is equal to 0 to 8. This guy, if we follow the previous rule that we have, the properties that we have, okay, you actually can separate them like this. Fx dx 0 to 5 plus with fx dx integrate 5 to 8. Okay, this guy we already know. 0 to 8 is equal to 10. 0 to 5 we also know already, which is 5, plus with the one that we don't know is fx dx 5 to 8. This is the one that we want to know, right? So if you want to know this, then you can bring 5 to the left side. You're going to get 10 minus with 5 equal to fx, integrate fx from 5 to 8, which is your final answer is equal to 5. Like this. Okay. So we go through another example here. Okay. The same question also. If it is known that fx starting from 1 to 5 is negative 3 and from 2 to 5 is equal to 4, find the value of fx from 1 to 2. So let's say right now, if you check, right, we have fx integrate starting from 1 to 5. You actually can use the properties, which is we separate fx dx is equal to 1 to 2 plus with fx dx starting from 2 to 5. So do we have 1 to 5? Yes, which is negative 3. Do we have 1 to 2? No, this is the guy that we want to find. Okay, 1 to 2, and then plus with 5 to 2, do we have? Yes, which is 4. And in order for you to find fx dx integrate from 1 to 2, you just move 4 to the left side. You're going to get negative 3 minus with 4 equal to fx. So integrate from 1 to 2 equal to negative 7. So this is your final answer. So that's it for this subtopic. We will go through another subtopic, which is area under a curve or area between two curves, in another video. Thank you.